Hi everyone. Today we are going to discuss about the preliminaries of the natural language processing course which all of you have taken. And today we won't be discussing much about the things which are related to NLP per se, but this is more like a brief recap of other things which you have already studied and you might be requiring them through the course uh, of this exercise. And my name is Shounak, and I am a research scholar from IIT Kharagpur. And okay, so let's begin the session. So, what we will be talking about today is briefly about the different types of languages and their hierarchies. And you'll also have a bit of recap of these mathematical principles related to probabilities and matrices. So, this is more like a interactive session, and today as such we will be looking at multiple choice questions, which will also help you recap many of the things which might have got blurred with time. And so yeah, let's begin. And I would expect that you respond to the questions and answer if you know them, before we actually start discussing the solutions in depth. All right, so let's start. So the first question, this is regarding the different type of languages which you must have studied in the theory of computation course which you have had. So this talks about, uh, you have these four statements and you have to recognize which of them is false. So the first is that context free language is a subset of context sensitive language. Regular language is a subset of context sensitive language. CSL is a subset of CFL. And finally, recursively enumerable language is a superset of regular language. So, yeah, like if you know the answer, you can unmute and respond. So, like, would you like
So
to
I
take a
think
guess?
three is the answer. Yes, it is not a sub.
Yes, this is exactly correct. 3 is the answer because all the other statements 1, 2, and 4 are correct. Context sensitive language is not a subset of context free language, but rather vice versa. So we get to know this from, this is a very famous diagram, you must have seen it. This is known as the Chomsky hierarchy of languages. And so if you look at it, so regular language is the smallest set among this, and each is like a subset of the next one. So yeah, like regular languages are a subset of CFLs. CFLs are subsets of CSLs, and CSLs are a subset of recursively enumerable languages. So yeah, let's go on to the next question. So this is a classic probability question. So you have a bag one which contains four blue and six red balls, while another bag two it contains four blue and three red balls. So one ball is drawn at random from one of the bags and it is found to be red. So what is the probability that it was drawn from the second bag? So while you don't need to work it out per se, but would you like to answer as in, what do you think is the principle we use for solving these kind of problems? Do you have any idea?
Okay. Okay. So firstly, I'll need to find the probability of uh, picking up a red ball from bag one and then bag two, and then we have to sum it both.
Mhm.
Okay. So the theorem that I need to use is Bayes theorem
Yeah,
because
exactly.
it's
Exactly.
given that it needs to be drawn from bag two.
Exactly. So you are right. So let's just have a quick look at how we solve these problems. So if you can see, as we said, so the theorem that will be used is the Bayes theorem. So we want to calculate probability that the bag is the second bag given that the ball chosen is red. So P of B2 given R, and that can be written as, like, you know how Bayes theorem works, we reverse the conditionalities and the denominator becomes a sum of all possible situations. So yeah, so basically this, the probability of getting of having chosen back 2 given the ball is red is like probability, first you need to choose the back 2 with a probability P of B2, and then you need to choose a red ball R from the back 2, and this is, you have to divide this by both the situations where you can get a red ball. So you can also get a red ball from, just one second, sorry for the interruption. So you can also get a red ball from the bag 1. So those two possibilities need to be considered in the denominator. All right, so let's move on. So this is a question regarding grammar. So which of the following can parse a context-free grammar? Any
I believe
guesses?
all of the above can parse.
Yes, yes, you are right. All of the above can parse CFGs. Then we go on to another question. So the pumping lemma, you must have heard of it. So there are pumping lemma. Uh, there are multiple versions of the pumping lemma, but overall, the pumping lemma is used to often prove that a language is one context free, two not context free, three regular, four none of the above. So you can take a guess.
Yes, pumping lemma, I think it cannot prove that it is a regular language. Also, similar case for context-free languages. So, I believe the second option is correct. That is, it cannot prove that it is a regular language.
Yes. So, as we know, you cannot prove that a language is context free or regular using pumping lemma. But the other side can be proved. That is, it is not context free or not regular. So, that can be proved using pumping lemma. There are two versions of the pumping lemma. One can be used to prove that a language is not regular, and the more advanced version can be used to prove that a language is not context free. Okay. So then we come down to this. So when a top-down approach of dynamic programming is applied to a problem, it usually so you have to understand in terms of the time complexity and space complexity. So does it decrease both? Time decreases, space increases, time increases, space decreases, or increases both?
Okay, are you asking in terms of solving that as we go on solving the problem? Are you asking in terms of that?
Yes, yes,
Okay, so as we go on solving the problem, I think the time will decrease, but we need to uh, save the other answers that are already solved. So the space complexity will keep on increasing.
yes, you are exactly right. So, as we know, that dynamic programming uses a technique known as memoization, where we solve small subproblems. So, we start in a top-down manner and we go to the bottom. We solve the smallest subproblems and then we recursively come up. So, what this does is that it greatly reduces the time needed to calculate those small values because we don't need to calculate them again and again. But the trade-off is that we need some space to store those calculated values. So yes, the time complexity decreases and the space increases. You're right. Okay, let's go on to one more probability question. So suppose that the probability of an event A is zero point 0.2 and that of an event B is zero point 0.8, and also it's given that these two events are independent. So then calculate probability of A given B. So
Uh, since these two events are independent and probability of A is zero point 0.2, I think it will be zero point 0.2, but I'm
yes,
not quite sure.
yes, you are right. Since they are independent, which means is that whether event B happens or does not happen does not affect the chances of event A happening or not happening. So in colloquial terms, it means that the probability of A given B remains probability of A. So basically, the probability of A does not change given the condition of B, because A and B are independent. So yeah, you are right. It is point 2. And the explanation in mathematical terms is quite simple. So we know the formula of PA given B is PA intersection B by PB. And we also know from the definition of independent events that PA intersection B is PA into PB. So that is the mathematical proof of the same. Right. Uh, so one more GK question kind of. So the context free languages are closed under, there are, like, there are multiple operations which we can perform on languages like union, intersection, so on. So different type of languages are closed under different operations. Closed under means that if you take two languages and you perform an operation and the resultant language is also of the same type, then it's known as closed under. So uh, yeah, like the options here are intersection, complement, clean closure, and all of the above. So like an answer.
Yeah, I think it is clean closure because it is not closed under intersection and complement.
Yeah, you are correct, because as I said, it's quite general knowledge question kind of. Clean closure, CFLs are closed under clean closure, but they are not closed under intersection and complement. Yeah. Okay, let's now have a look at some of the mathematics. So this is, if A is a 4 cross 4 matrix. uh, Okay, so I think the question is a bit missing here. So the determinant of A is -1. So compute determinant of -3A.
Okay,
Like
the
it's not
determinant of
written,
A.
it's not written there in the question. I forgot to write it, but determinant of A is -1.
Okay, okay,
Uh, okay, so let me talk about this one. So there is a straightforward formula for this. So basically, this is the formula, that is determinant of k times, where k is a scalar, k times of a matrix A, which is n cross n, is given as k to the power n into the determinant of A. So as I said, determinant of A over here is -1, and k over here is 4. Sorry, k is -3 and n is 4. So if you just put it into the equation, it comes out to -81. So really what is important here is this formula, that k, determinant of ka is k to the power n into determinant of A. Okay,
okay, okay.
let's go on. So this is about regular expressions. So I guess you know that regular expressions are like a format using which we describe regular languages, so to say. I guess you are familiar with this notation, where plus refers to union, uh, concatenation is represented as it is, and like star represents the clean closure kind of. So yeah, you are now asked that you have to write the regular expression for all strings which start with AB and end with BBA. So what do you think is the answer?
So in the third option, I can see that it starts with A, B, and ends with BBA, and anything can come in between. So that I think is the answer.
Yes, you are right. Because if we just see what the other strings mean, I think that is important. So if you see, the first string is A B, A star, B star, BBA. So while you have starting with AB and ending with BBA, there is A star, B star in between. So A star, B star comes out to be something like any number of A's followed by any number of B's. So it does not represent all possible strings which start with AB and end with BBA, because for that the middle portion can be any combination and permutation of A's and B's, but this configuration does not allow any combination. It only allows any number of A's followed by any number of B's. So A and B's cannot get mixed up in this configuration, so this one does not work out. Also for the next one, if you see, it's AB, then followed by AB star, and then BBA. So like AB whole star. So what this means is that this AB part will get repeated many times. So this will come as like AB, then AB, 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 any number of times of a AB, and then BBA. So again, like the previous example, this also does not cover all possible permutation combinations. So the answer is actually this one. So let me also explain little briefly. So this is the union operation. So this means either A or B star. So using this kind of regular expression, you can actually generate any possible permutation and combination of A's and B's. So that is why this is the answer. Okay. Now there is a question on matrices. So you must have learnt about eigenvalues, eigenvectors previously. So you are asked to find all eigenvalues of the matrix A, which is given like this. Again, you don't need to work it out per se, but could you just describe how you would go on to solve this kind of a problem?
Okay, so to find the eigenvalues, I need to calculate the determinant. I need to find the determinant of A minus lambda into identity matrix of the same size.
Yes.
That is of 3 plus 3 in this case.
Yes.
And I need to find the determinant. If I solve the determinant, I'll get the three values of lambda.
Yeah, like just to correct you a bit, that you don't need to calculate the determinant per se. You need to put it in the equation of determinant A minus lambda I equal to 0. So using that equation, you will get multiple roots for lambda, and these roots will be the eigenvalues themselves. So yeah, you what you said is right. Just made a small
Yes.
correction to that. So yeah, let's just go through how this is worked out. So the answers in this case are 0, 3 and -4. Let's just work it out in the raw way, so to say, or in the mechanical way. So yeah, as I said, you have to put in this equation A minus lambda I, mod of A minus lambda I is equal to 0. By mod here I mean determinants specifically. So yeah, you put it in this equation, and now you must have learned a lot of techniques regarding determinants in your school mathematics. But so you can apply those techniques like adding rows and so on, which can help to cancel out many things usually. But even if you are not able to do that, you can just directly do the again the mechanical way of calculating determinants, which I have followed here for brevity case, and I have expanded along this last column. So yeah, we take one and we have this thing over here, and then we have this -1 minus lambda and into this thing over here. So if you just take a bit of patience and solve it, we will see that the constants get eliminated. The constants getting eliminated means one of the roots is 0, and then the rest of it is like a simple quadratic equation. Okay, so I guess this was also comprehensible. Okay, let's come to Levenstein distance. So the question asks, what is the Levenstein or the edit distance between the strings sweet and swift? And you have to assume the costs of insertion, deletion and substitution as 1, 1 and 2. So let me just give a bit of a preview of Levenstein distance. So Levenstein distance means how many or what is the cost of an operation to change this string, say sweet, into the string swift. Now you are allowed to do any number of insertion, deletion or substitution operations anywhere to convert this string to this, and the costs are given as said. uh, so yeah, like anybody has an idea how we calculate the edit distance?
So it goes on like a dynamic programming method.
Yes, exactly. Exactly. So you have to do a dynamic programming approach. Now, because the example here is quite simplistic, you can see that these are the differences, like SW double ET. So there are two E's over here, whereas in Swift you have SWIFT. So the change is between the two E's, and here you have I and F. So for this example, we can just look at it and say that the cost will be 4, because we need to remove the two E's and insert the I and F. So either you have two removal and two insertion operations, or two substitution operations, both of which cost 4. So the answer here is 4. But just for the sake of understanding how to do this dynamic programming approach, uh, I decided to solve this one in the classical way. All right. So let's just have a quick walk through how we would do that. So you have what you need to do is you need to write the two words along two axes of a table, and here you can see on the top I have written Swift, and on the left hand side it will be Sweet. The rest will come as we go and discuss. So how do we fill up these values? So it's pretty simple. When you have just one letter over here, then you need to calculate what is the cost or the edit distance from changing this one letter to as many letters or words, as many letters you are covering here. So change from S to S is nothing, 0. From S to SW you need to add 1. From S to SWI 2, and so 3 and 4. Okay, so this is how you populate the like the topmost edge and also the leftmost edge. So once you have populated those, the other values can be simply calculated using a very simplistic formula. So the formula works like this, that whenever you are comparing, say, let us look at this W over here. So on the left hand side you have SW, and here you have Swift. So change from SW to S, you need to delete one character. So that is a change of 1. From SW to SW. Okay, so let's just have a look from here on. So you need to fill up this value, and you have these values. Now all other values can be calculated using dynamic programming approach. So how do we do that? So whenever you are, say you are trying to calculate this particular value, so how do we do it? We check if the two characters that are being where the this cell, whichever cell you are considering, it will be an intersection of two characters, right? So if the two characters are exactly same, then we can just copy the left diagonal value. We can just copy the value over here and put it down. Fine. What if it is not the same? If it is not the same, then you need to understand that you how we calculate is that we need to take the minimum among all the three possible operations we can take. So what are the three operations over here? We know that insertion, deletion, and substitution. So if you consider this cell, from here to here is an insertion operation. From here to here is a deletion operation, and from here to here is a substitution operation. So whatever is the cost in the boxes, with that you need to add whatever is the cost of those individual operations, and then see which is the minimum possible value you can take. So that will be taken then. So here obviously it's 0 plus 1 is 1. Over here you will have 1 plus 2 3. Here also 2 plus 1 3. So since the minimum is 1, we copy 1. And similar process for this and this also. So 1 plus 1 is 2, 2 plus 2 is 4, and 3 plus 1 is also 4. So we have 2 over here, and likewise 3. Remember, these are the things we need to do when the characters are different. When they are same, we can just copy the left diagonal. Okay. So we go one step further. Again, you see this value you need to populate using your like this is the base value or the base case. So that is 2 over here. And then all subsequent values you can calculate using the formula we just discussed. And once you finish, the right bottom corner of the table, that will give you the final edit distance. And so as we see in this case, this is 4. So I guess that is a bit clear.
Okay, so as we go down the table, so the table keeps on solving itself. Like if I consider just the first part of the table where just S was shown and Swift was shown. So if I consider 4 as the number, so comparing S and Swift, this is the answer, right?
Yes, yes, yes.
Okay.
Like you have to this position over here is we are calculating edit distance between uh, any row or any cell. Suppose we consider this cell. Okay. So
Yes.
that means we are considering the edit distance between SWI and SWE. So yeah,
Okay.
just as you said, it keeps solving itself because we recursively consider each character of one string when we are comparing it with the entirety of the other string.
Okay.
Okay. And okay, so this is the last question for this session. So this is about time complexity. As you know, time complexity is a expression we use for estimating how much time would a program take based on the size of its input. So as the input becomes larger, how does the time taken get affected? So Fibonacci numbers, you know that Fibonacci numbers are these series of numbers where like any Fibonacci number is like the sum of its previous two numbers. So that is how we calculate. And you know the series starts with 0 and 1 as the first two numbers, and then we keep on just adding the previous two numbers to get new numbers in the sequence. So yeah, so what is the expression of time complexity? Does anybody know?
Yes, since the Fibonacci numbers are depending on the previous two numbers, so it will be the last one, I think. Tn equals to Tn minus 1 plus Tn minus 2, because it depends
Ex-
on those two numbers only.
Yes, exactly. Since you are calculating here using pure recursion, where you do not have any kind of dynamic programming based memorization or other approaches, so everything will get calculated again and again on their own. So basically, when if you need to find out Tn, you first need to find out n minus one and n minus two, and we just simply add those two up. This is also clear if you have a look at this chart which we have for the fifth Fibonacci number. So, so for calculating fifth 5, you need fifth 4 and fifth 3. Fifth 4, you need fifth 3 and fifth 2. Then fifth 3, you need fifth 2 and fifth 1 and so on. So this is how we get this shape of the tree. And that is actually, so this is Tn minus 1 and this is Tn minus 2. All right. Okay. So yeah, that's the end for today. I hope that this was a good enough introduction to what is to come. And obviously, from the next weeks onward, we will be discussing about pure applications of NLP. This is just like a precursor to them. Um, okay. If you have any doubts, you may ask.
That was fine.
Okay then. Okay. Thank you then. We will meet next week.
Thank you.